So the angular momentum is integer multiple of h by 2 pi. This Bohr's postulate. So there are not too many formulas to remember, only few of them. First one is the radius. Remember this one. And for energy, you have to remember this one. Okay. And to convert electron volts joules, you have to remember this one. This you should know. And energy will go as 1 by n square. Radius will go as n square. And with z, radius will go as 1 by z. If z is increasing, the radius will decrease because the attractive force between the nucleus and the electron will increase. So that will bring the radius closer. Energy will go as z. You can check this one in Google. It will increase as z. Yeah, it goes as z square. Yeah, it goes as z square. Okay. Minus 13.6 z square by n square. I'll just put it straight away. So 13.6 can remember, and it's 1 by n square. And as z increases, it will increase as z square. Radius will increase as z, not z square. Radius will, decrease as z, raised to the power 1. So radius will decrease, energy will increase. So the theory part is clear. Today solve some problems. NCERT exercise. They are straightforward questions. So this one, shortest wavelength means highest frequency. So highest frequency corresponds to jump from infinity to the Paschen is Lyman-Balmer Paschen n equal to 3. So n equal to 3 is the ground state or the final state, and the jump corresponding to infinity to 3 is the shortest wavelength. Energy is given as minus 13.6 by n square. It's hydrogen, right? So z square is not required. So Paschen means in Lyman-Balmer Paschen, so 3. So n equal to 3, and from infinity to this jump is maximum energy difference. So this will give me the maximum frequency and minimum wavelength. So this jump will correspond to frequency maximum and wavelength minimum. Okay, so if you put final minus initial, right? So final energy is 0, outermost is thing, and initial energy is minus 13.6 by 3 square, that is 9. This is the electron volts. So if I need to get the wavelength, right? So 1.6 into 10 raised to minus 19 joules. So this is H into nu, which is H into C by lambda. Nu is C by lambda. So lambda will become H is 6.667, 10 raised to minus 34. And C is 3 into 10 raised to 8 divided by 13.6 and 1.6 into 9. So this is lambda. So 3, 6. So this is approximately same. 2. And then this is 12, right? 12, 30. So if we cancel these two approximately, so we will approximately 10, 10 raised to 9. So 10 raised to minus 25 meters. 10 raised to minus 19. What happened to that? I missed this one. C by lambda, lambda is there. 1.6, 10 raised to minus 19 is there. No? So here we'll have 10 raised to minus 19. So this will become plus 19. So 10 raised to minus 6 meters. Approximate value. So 12.3. 820 nanometer. So this in nanometer would be 10 raised to minus 9, right? So 1000 nanometer. Okay, the book we are given 820. I done approximation, right? So obviously, so order of magnitude is correct. Okay, so shortest way means the frequency has to be maximum. Frequency has to be maximum means the energy difference has to be maximum. So you get the maximum energy difference if the jump is from infinity to the final state. Once I say fast gen, it is the n equal to 3 is the final state. Lyman is the first one, Balmer is second, fast gen is third, next is bracket, last one is P-fan. So for fast gen series, the final state is n equal to 3. To get a maximum energy difference, I have to jump from infinity to the least possible, n equal to 3. So this jump will correspond to the energy difference of 13.6 by infinity square, that is 0. Final state, initial state is n equal to 3. So if you put n equal to 3, I'll get this much energy. To do the energy difference, I have to convert to joules. So multiply with this electron charge. So this energy is the energy of the photon which is come out, which is h into nu, and nu is c by lambda. So all constants are known. So I have to find the lambda. H's value is given, SI units, C is known, and this. So this is the answer. So the difference of 2.3 electron volts separates 2 levels in an atom. What is the frequency? Upper level below the level. Yeah. So this is the same thing. This is the energy difference of 2 levels. So this first level, this second level, this energy difference is 2.3 electron volts. So what is the frequency radiation between the atom? Make a transition from up. So basically the electron is making the transition. The electron is jumping from the highest state to the lower state. So it jumps from here to here. It will give out a photon. Corresponding is energy difference. So this energy difference is 2.3 electron volts. That should be equal to h into nu. So this had to convert to joules. 1.6 into 10 raised to minus 19 joules. You have to find the frequency, right? So just the nu. So h into nu. So from this, I'll get the nu. I'm not doing the calculation. Okay. So is this clear? Actually, I discussed these questions in the class itself, but few people are listening. So this is clear, no? 12.4, 12.5, the ground state of energy. And what is the? So this is another simple concept. So energy of an electron in say nth orbit is kinetic energy plus potential energy corresponding to the nth orbit. So usually we like, suppose this is, for example, minus 100, potential will be negative and will be double of it, minus 200. And this kinetic will make it a little bit positive, so it will be plus 100. So this is a simple thing. This is how it will look like. So for example, it's minus 13.6. So this will be twice of this one. So it is 27.2, right? Yeah, 27.2. And this will be plus 13.6. So total will be negative. Okay. And potential will be negative and it will be more negative, double of this total energy. So to make it a little bit positive, kinetic should be positive and will be equal to the total energy. So here, he's talking about the ground state of the hydrogen atom. So the total is minus 13.6. So the potential will be double of this thing. So it will be 27.2 and the kinetic will be plus 13.6. Okay, so this is in electron volts. If you have to convert to joules, you have to multiply that into 1.6 into 10 raised to minus 90. So 12.5, yeah, they are given electrons only. Is it clear? So remember the simple logic. Total is negative, potential is more negative, and it will be double of that. So to make it less negative, kinetic should be positive or equal to the value of the total energy. So this logic, if you remember, you can solve it. The hydrogen atom is excited from. Okay, this is trivial question. They are given initially. So here the electron is jumping from n equal to 1 to a higher state. So energy has to be supplied. So absorbs a photon, excites it 2. So final level is this is the final level. Initial level is the ground level. Okay. So this is a single proton because hydrogen atom. So this is n equal to 1 and n equal to 4 is here. N equal to infinity be here. This is the maximum energy corresponding to 0. This is minus 13.6. This will be less negative. So this energy difference. So here I'm supplying energy. The transition is from lower energy state to higher energy state. So here I have to supply energy in form of radiation I can give. Okay, so this energy of the photon is the increasing energy of this electron, which is initial energy. So final energy minus initial energy, which is minus 13.6 by 16 minus of minus 13.6 by 1 square, which is 1. 16 because 4 square. Energy of this level is 13.6 by 4. 4 square is 16. So this will be minus, or I can put 13.6 outside, minus 1 by 16 plus 1. Okay. So if you put these values, I'll get the frequency. I'm not going to simplify. You can do it. So you should get this frequency. Have they asked the wavelength? Wavelength, okay. Wavelength also you can get. Once you get the frequency, you can put wavelength as C by nu, because C is nu to lambda. Electromagnetic wave, C is nu to lambda. Once I know nu, I know C. So from there I can find the wavelength lambda.
Okay, sir.
Yeah.
Sir, physics com question paper velirida varda, sir.
Yeah, principal is giving.
You're not setting the question paper, sir?
No.
All right, sir. Okay, sir.
So from now on, I think it will be like that only. Okay. So expect.
Okay, sir.
Whatever. Right. So 12.6. So 12.7. All questions are simple only. A straightforward application of the formula. So if you have exam idea, it will be useful, because I think she's getting it for, I don't know. Okay, can anyone tell me how to do this one? You have to find the velocity of the electron, right? Velocity of the electron at n equal to 1. Let me call it V1, and similarly V2 and V3. Okay. So if I know kinetic energy K1, I can find V1, right? How do I find from K1 to V1? Anyone tell? K1 is known, say, from that I can find. How do I find V1? What is the relation between K1 and V1? K1 is the kinetic energy. It's half m V1 square, and m is nothing but the mass of the electron. And K is known because of this relation, minus 13.6 equal to minus 27.2 plus 13.6. This is nothing but the kinetic energy, right? So for n equal to 2, this will become minus 13.6 by 4. And kinetic energy will become plus 13.6 by 4. So K3 is 13.6 by 9. So K is known. Mass of the electrons is constantly to be given. So from there I can find the velocity, right? So first part is done. Speed is nothing but the velocity. Orbital period. So how is V and T related? Anyone tell? Once I know V, I should be able to find the period T. T is the time taken to complete one circle. So T is circumference 2 pi r by r is known because we have that formula, right? Rn equal to 0.53 angstrom units by, into n square. So into SI units become 10 raised to minus 10 meters. This conversion is correct, no? 0.53. Radius is 0.5 10 raised to minus 10. So use this formula list. So once I know the velocity, I can find the time period. T1, T2, T3 corresponding to the different orbits. Okay. So 12.8, the radius of the innermost hydrogen. Okay. Trivial question. This is R1. So R2 will be n square times, right? So it will be 4 times this one. and entry will be 9 times this one, because R goes as n square. R goes as n square. Okay, R1 is known. Once I know R1, to get R2, I have to multiply this one by 4 times. So the answer will be 12.8. So it'll be first be 4 times, so it's 20 point or 21.2 into 10 raised to minus 11. 21.2, sorry, 21.2 into 10 raised to minus 11. That is 2.12 into 10 raised to minus 10. Okay. Similarly, the next one, it will be 9 times this one. So it's approximately 5.3 into 10 raised to minus 10. 5.3, it is 4.77 into 10 raised to minus 10. That is what? 9 times this one. So 9 5s of 45. And then 40, so 47.7 into 10 raised to minus 11. 47.7, yeah, it's correct. Simple, no? Okay, next one. Yeah, this is a little bit simple logic. 12.9. So electron beam energy is this one. Bombarded gaseous hydrogen, so hydrogen atom. So single proton, one proton, and electron will be obviously when nothing is happening, electron will be the ground state, single electron, right? N equal to 1. But if I bombard with this electron, it can take this electron to some other higher orbit. Okay, so this energy level is minus 13.6 electron volts. So this 12.5 electron volts can take you to a maximum possible level of minus 13.6 plus 12.5. That will make it minus 1.1 electron volt. Getting the idea, right? Because to this minus 13.6, I'm adding energy of plus 12.5. So that will make it less negative. So it can jump to minus 1.1 electron volts. So only thing now we have to figure out is whether this energy level, this value of energy corresponds to some orbit or some in-between place. Okay, so if this level, if it corresponds to this particular value of R, which is not possible, then this electron will make this outside electron will make it jump from here to this level only. Okay, so that you have to figure out. So n equal to 1, the value of the energy is this one. So n equal to 2 means 13.6 by 13.6 by 4. That's equal to 4 p sort of 3 point something. So next will be corresponding to 9. So 13.6 by 9 is 9 ones are 9, and then 45. Right? So 1.5. So there is minus 1.5 here. Okay, and the next one is minus 13.6 by 4 square, 16, which is less than 1. So fourth one will be here, n equal to 4. So this electron beam can take this electron from here to some level here, but there's no level here. So it will take it to n equal to 1, 2, 3, n equal to 3 level. Okay, so the electron beam of 12.5 electron volts will take this electron from here to this level. After that, there is some additional energy which won't be used. That will be just wasted. Okay, so once I take this electron to this higher level and then leave it, the electron will come try to get back to its ground state. So from this level, n equal to 3, you can jump to n equal to 2. That is one jumping. And the second possibility is jump from n equal to 3 to n equal to 2. So this jump will give me one photon, photon of one frequency, and this jump will give me second frequency photon. So okay, you don't have to find the frequency, you just have to say what series it is. So the jump is to the final state of n equal to 1. Okay, this is not a good question. Okay, the series is Lyman series. Okay, and only not the full series is possible, only the first two lines of the series is possible. First jump is from or the last two lines, which is correspond to n equal to 3, 2. Okay, I made a mistake here. One jump is from n equal to 3 to final state of, because the ground state is the final stable state. So jump has to end in this final state. Okay, one more complication is there. So one jump is this one. Second jump is from n equal to 4 to this jump. Another jump is, but not n equal to 4. It does not go to n equal to 4. N equal to 3. Okay. See, this is one jump, and third jump is from here to here. Like this electron here, it can make two successive jumps. One is to from 3 to 2, and second jump from 2 to 1. Or another possibility is it can jump directly from 3 to 1. So is there any other possibility? Only three possibilities. Jumping from 3 to 1, it can happen straight, or you can jump from 3 to 2, and you can jump from 3 to 1. So three frequencies or three wavelengths are possible. So question is not clear. Well, just a minute. Connection got cut, is it?
Yes, sir.
Okay. Yeah. So two jumps. See these two jumps, n equal to 3 to n equal to 1, and from n equal to 2 to n equal to 1, this corresponds to Lyman series, because Lyman series is defined by the final state, which is n equal to 1. So two lines of Lyman series, okay, and then one line of this is Balmer, right? So this jump is Balmer. So two lines of Lyman series and one line of the first line of the Balmer series. So three frequencies are possible, or three wavelengths are possible. So Lyman series, two lines, okay, and Balmer series, one line. Is it clear? I'm not doing the calculation. It's simple only. Because whatever energy difference you get, okay, that you have to put equal to h nu or hc by lambda. H is known, c is known. From that I can find lambda. And 13.6 electron volt you convert to joules, multiply by 1.6 into 10 to the minus 19. So you put everything in SI units, you'll get the answer in nanometer. Okay. 1210 first quantum number that has. Okay, this is not a bad. So okay, this is talking about sun and earth. So sun is at the center and earth is here. Okay. So earth is going in a circular orbit with some radius, right? Okay. So for any mass, I can associate a wavelength, like particle is behaving like a wave. And the relation is lambda is what is the relation? basically you have the momentum of the photon is h nu by c, which is h by lambda. So from that, we get the lambda is h by lambda. So lambda is h by p. Okay, so h is a constant, p is known because p is nothing but mass of the earth into velocity of the earth. Okay, mass of this is a constant, velocity of the you can find out. Velocity of the earth is known because radius of the orbit of the earth is known. Mass of this is a constant that's given. Velocity of the earth is 2 pi r, the radius of the earth's orbit, divided by the time period, which is 24 hours. Sorry, 365 days. This earth going around the sun, 365 days. To convert into SI units, 1 day is 24 hours and 1 hour is 3600 seconds. So this is the time period in seconds. This RE is radius of the, distance of the earth from the sun. Those things are known. So from this, I know the momentum. Okay, so 2 pi RE should be equal to some integer multiples of the wavelength, lambda. That is the quantization condition, right? There is a wavelength corresponding to this earth, because any particle can behave like a wave. So even the massive mass like earth can behave like a wave with particular frequency lambda. That frequency I can find out by knowing the momentum. Momentum I found by using this one. So once I know the momentum, I can find the lambda. And once I know the lambda, I can find n, because this RE is known. Okay, so I'll just search in the net. This question is not there. So that's what they have done. MVR is n into h by 2 pi. Okay, so n is MVR. So V, velocity of the earth, you have to find out. R is this distance between the earth and the sun. That's a known constant. Velocity of the earth is also known in the sense the method I said. Velocity of the earth is 2 pi r by time period. Okay, this is the velocity of the earth. So something is also known quantity. If you put that thing, you'll get the n value as 2.6 into 27. So it's a very, very large value. So that's why, in some sense, you can say this quantum or the discretization, discreteness of this thing which you see in the atomic level, you cannot see in the microscopic level, but the value of n is very okay. So that is the main conclusion of this solving this example. The value of n is very high. So that's why you don't see quantum phenomena in the macroscopic world. So only few people are there. So what should I do now? Try to solve this questions from this Learn CBSE.
Yes, sir.
And they have given the solution also, right? And if anyone has some problem, just WhatsApp me, even my personal WhatsApp number. I'll see whether I should have another session or not. So only 3 minutes left. After that, it'll get cut. So atomic physics discussion, it's enough, no?
Enough, sir.
Akshay.
Sir.
So concepts are clear.
Hi, sir.
The only formula I didn't discuss is this one. So the first one is basically the energy difference. What was the energy difference between this some n and this one that I have put as h into nu. So from there I'll get the nu as this one. Got it? No. Lyman series jump from n equal to some value to 1, right? So the energy difference between those two levels is 1 by n square minus 1 by 1 square. Okay, so that energy difference you have to put to h into nu. So nu, h you bring it this side, that will get combined in this constant. So that's how you get all these formulas. So this formula is not different from this formula. This once I know this formula, I can get these formulas. Okay, because this formula is jump from some value of n to this one. So the difference between those two energy levels, say E3 minus E2, that I can get from this formula. That I put it to h into nu. So that nu is I divide by h on this side. I'll get this formula. Is it clear? So this formula is basically the energy formula. And the idea the difference in the energy will give me the photon of energy h nu. Okay. So the so atomic physics, I think discussion is enough. If you want discussion for AC, I'll send a WhatsApp message. If you want, let me know. Okay. Or if you have any further doubts in atomic physics, let me know. Okay.
Okay, sir.
Okay, sir.
Atomic physics is easy, no?
Fine, sir, now.
Yeah. So formulas, just remember them. So with that and simple logic, you can solve it. Okay. And learn CBSE solutions are there. So you should be able to figure out if you're not getting it. Okay. So AC, for AC, do you need discussion or not? For AC chapter? Akshay, Arivoli.
Sure.
For AC chapter, do you need a session?
No, sir. We have already done for the previous exam, no, sir. So I don't think it's necessary, sir.
Okay. So the meeting will get cut. So I'll contact by WhatsApp. So let me see how other people respond.
Okay, sir.
Okay,
Okay,
bye.
sir. Thank you, sir.
Bye. All the best.
Thank you, sir. Thank you, sir.
You should do well. It's a 2 easy chapter. Just go with that frame of mind.
Okay, sir.
Okay, bye.